Okay, so we're starting. So this entire chapter is about hydrocarbons or organic compounds. Organic compounds are those that contain hydrogen and carbon. They have to. So question 1. Which of the following represents an organic compound? We know organic compound has to have carbon and hydrogen in it. So we see here, potassium chloride, can't be that one. Nitrogen, hydrogen. If this was carbon, it could be that one, but no carbon. Chlorine, can't be that one. Silicone, hydrogen, can't be that one, so it has to be D. All right, next one. All the following statements about organic compounds are true except, we'll go through. Organic compounds contain carbon. We know that this is true. And remember, covalent bonds are between two nonmetals, and carbon and hydrogen are both nonmetals, so this is true. We'll get into this later, but organic compounds do contain chains and rings. Organic compounds can contain functional groups. This is just telling that there's like further ways to detail organic compounds, which there is. You'll get into that a little later. So this is the only one that isn't true. Organic compounds do occur naturally. That's why they're organic, because they occur naturally. Okay. So we have here, there is several different kind of, what do we call them? Different formulas when representing an organic compound. So you have a line formula. A line formula, something like this. I'll explain it to you because it's a little hard. We have condensed. Condensed is all of these numbers are condensed like in a line one by one. We have the expanded. Structural formula, which is this one. This one is the expanded structural formula, because it's like it forms like a structure. That's how I remember it. Skeletal would be different. Okay. So when looking at carbon, or they're looking at organic compounds, so we're working with the line formula here. Carbon. Remember, carbon can bond with four atoms because it wants to have 8 valence electrons and only has 4 valence electrons, so it can bond with 4 different atoms. So if you look here, you see this carbon, it's bonding with 1 atom, 2 atom, 3 atom, 4 atom. And then when we're looking at a line formula, how to understand a line formula, each dot is a carbon atom. So here, so each like end and with each like pointy part is as a carbon atom. So 1 carbon atom here, 2 carbon atoms, 3 carbon atoms, 4 carbon atoms, 5 carbon atoms. And what we get from this is we know that this carbon atom here, it's already bonding with this one. So it can bond with 3 more hydrogens. This one right here, it's already bonding with that one and bonding with that one. So it can only bond with 2 more. This one, same thing, only 2 more. Only 2 more. But this one is only bonding with 1. It could bond with 3 more. So if we count all these lines, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That tells us that there is 12 hydrogen atoms in a line formula like this. So we can use that to decipher this. So here, only bonding with 1, there's 3. Bonding with 2 already, that's 2, 5, 7, and then 10. So it's 10 in this one. This one, there's 3, 2, it's bonding with 3. It's bonding with that one, and that one. So 3, 2, 1, 2, 3. So it's 6, 8, 10, 11. There. For this one, 3, 6, 9. Remember, each dot, so that middle one's gonna be a carbon. But it's already bonding with 4, so we don't card that. So 3, 6, 9. So 9 in this one. This one, so if you see a shape, if you see a hexagon like this with like 3 lines in the middle of it, it's called a benzene, something like that. It has a total of 6 carbons and 6 hydrogens. But if it's connected together with another benzene, we're removing one of those carbons. So basically we have 2, 4, 6, and then these count as 1, so 7, 8. So this one has hydrogen atoms, which is why it is the one with the least. So what has a straight chain alkane or alkane? Alkanes are a kind of organic compound. So alkane is a type of organic compound. They always have a single bond. Alkenes, double bond, and alkynes, a triple bond. That's important for later. So if we're looking for a type of alkane that is straight chained, we look in this graph. So we look up there, C2H4, that's not up there. C3HAO, there's no O's, it can't be that one. C5H12, that could be one. C6H12, that's not on there. So we know it's C5H12 is our straight chain alkane. Okay, now here it's a little difficult. So first, count all of the carbons. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 carbons. There's a couple different ways you could solve this. First, you could count like the carbons or the hydrogens. You know that this one can respond with 3 more. That one can do 3 more. This one can only do 1, so it's connected to 3. You could do all that. It's the harder way. You could find that we have C10. If you just look down here, C10, that means we have 22 hydrogen atoms. Or you can do this formula. 2. Okay, so once we find the number of carbons, we know the number of carbons is 10. So that n equals 10. So we do 2 times n, which is 10, and plus 2. So 2 times 10 is 20, plus 2 equals 22. So we can figure this out, that this has 22 hydrogen atoms. All right, next. So remember how we draw the line formulas? Remember each of these is just a carbon. So we have heptane. Heptane is 7, or you can count it from here. 1, 2, 3, 4, 5, 6, 7. So you just start 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay. Correct. Now we just do this for a while. Hexane means 3, 6. So 1, 2, 3, 6. Okay. Nonane, that means there's 9, 3, 4, 5, 6, 7, 8, 9. Octane, that means there's 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then now we have this condensed structure. So with structures like these, so count how many C's there are. There's gonna be 1, 2. We can't count this one because it doesn't know. 3, 4, 5. So look for the one that has 5 C's in it. So this one has 1, 2, 3, 5, could be that one. 1, 2, 3, 4, can't be that one. 1, 2, 3, 4, 5, could be that one. 1, 2, 3, 4, 5, could be this one. So we just know it's not that one. And now we see that it is double bonded to this O, which tells us that there's going to be 2 O's here. We already know there's 2 O's here. So look at this one, there's 2 O's, 2 O's, 2 O's. But we know that this CH3 is first. So CH3 is first. It can't be this one because CH3 isn't first. CH3 is first. And we go from CH3, CO2, and then another CH2, CH2, and then CH3. Well, if we look at this one, we go to CH3. And we know that these can bond with 2. So that means it has to be 1. Okay. Next one. We have CH3, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Can't be that one. Can't be that one. 1, 2, 3, 4. It can't be any of those. So then it has to be 1. Just by counting how many carbons we have. Okay. This one. So remember, this is the benzene. It has C6H6. Remember that. So because it has C6H6, we gotta look for those that have C6H6. That one doesn't, that one doesn't. So we gotta cross those out. And then it bonds with this carbon here that is bonding with 2 O's and 1 H. So, but since, we gotta remember, since this is bonding with another atom, it's gonna lose a hydrogen that it can bond with. So in total, if we have 6 here, minus 1, we have 5. And then another hydrogen there already, that's gonna give us 6 total hydrogens. So since we need 6, it can't be this one because there's 7 hydrogens. We already crossed these out. So it has to be this one, it has to be 1. Whoops, I lied. Wait, it's 2. Oh, I know, it has to be 3. It's 3 because we're removing the H from that, because and then it becomes C6H5, and then that H is being brought to the back. Okay, next one, skeletal structure. We're asking for how many carbon atoms. We have 1, 2, 3, 4. 4 carbons there. How many carbons here? 1, 2, 3, 4, 5, 6, 7. We have 7 carbon atoms here. How many carbon atoms here? 1, 2, 3, 4, 5. Okay, now it's asking for how many hydrogen atoms. So we can just calculate how many. So we have 1, 2, 3, 4, 5, 6, 7. So we have 7 carbon atoms. And if we just look down here, we have 16. Or you could do this formula. We know that N is 7, so 7 times 2 is 14, plus 2 is 16. Okay, and then 16 hydrogens. So if you just count the amount of carbons, and if you just consult this graph, you can look how many hydrogens there is. Let me split these into a couple of videos. Okay, for this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 carbon. If we look, that means there's 20 hydrogen. Okay. We'll do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10. That means there's 22 hydrogens. I'm gonna answer in too many sig figs. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are just 20. Okay. And then sometimes it'll just want in a certain amount of sig figs, just round to the nearest like 10. Okay. And then we'll learn about this one in the next video.